Hello friends, welcome to engineering tutorial. So we will resume our discussion on network theorems, and so far in the previous videos related to network theorems we covered the Thevenin theorem, the application of Thevenin theorem, and it was applied to circuits involving only independent sources, both voltage or current. So in the next series of videos we will be covering the application of Thevenin theorem to circuits involving dependent sources. Now we have discussed the dependent sources thing with superposition theorem, and I have also made a separate video on what are dependent sources, what are the different types of dependent sources, so you can check that video. So I will not be covering all those things in this video. Here we will straight go into the application of Thevenin theorem to a particular circuit involving dependent source. Okay, so here we have this circuit. It consists of a number of resistors. We have an independent current source 5 ampere, and here this is a dependent voltage source 2 Vx. It is a voltage dependent voltage source. This voltage, its value is dependent on this voltage drop across this 4 ohm resistor. Okay, so this makes the circuit important, voltage dependent voltage source. Okay, so here we have to find VTH and RTH. So first let us find VTH calculation. For that, let us redraw the circuit again. It will be like this. Okay, so here we have redrawn this circuit for VTH calculation. This is the Thevenin voltage. Okay, now here we will be using mesh analysis to determine VTH. So let us assign the mesh currents. Let's say this current is I1 flowing in clockwise direction. This current, let's say it is I2 also in clockwise, and this current is I3 also in clockwise directions. So now we have to write the mesh equations. Here there is no current flowing because it is open circuit. So we have to write the mesh equations. Important thing to identify here is that I1 is equal to 5 ampere. See, the direction of 5 ampere and I1 is the same. So mesh 1 thing is done. Now mesh 2 and mesh 3. So to write the mesh equation for this second mesh, it will be like this. Here I2 is the predominant current. This is the reference current. Everything with respect to that, the others will be considered negative direction. I2 is moving upwards. So here this 4 ohm, I2 minus I1, like this will be the direction of the current. I2 is moving upwards, I1 is moving downwards, so the net current moving upwards will be I2 minus I1, upward direction because I2 is the reference, and this is the 4 ohm resistor, and the voltage drop will be like this. So here it will be minus 4 into I2 minus I1. Do not confuse with Vx, that is different. Okay, here minus 4 into I2 minus I1 minus, same here, 2 into I2 minus I3, same I2 minus I3, 2 ohm. Here again, let me clear it again here, 2 ohm. Through the 2 ohm resistor, I2 is flowing from left to right, I3 is flowing from right to left. So I2, as we are writing the mesh equation for the second mesh, so this will be the reference current, and it will be I2 minus I3 for this 2 ohm resistor. This one, I2 will be considered as the reference, I2 minus I3 for this upward mesh current, I2 minus I3. I have already made a video related to loop and branch currents, you can check that video also. And here it is minus 6I2, that is equal to 0. So let me erase this portion. Okay, so here it is, that implies minus 4I2 plus 4I1 minus 2I2 plus 2I3 minus 6I2 equals to 0. That implies, do not just substitute I1 with 5 right now, okay. First write the equation, then we'll do the other things. Bring all the coefficients together, I2, I2, it is minus 4I2 minus 6I2, just minus 12I2, minus 12I2 plus 4I1 plus 2I3 plus 2I3 is equal to 0. So this is the first equation, this is the second equation, this is the second equation. Another important equation here is the equation of Vx, to determine Vx. So here, as you see, this is the equation of Vx, the voltage drop across the 4 ohm resistor. Now the important thing here is which one you want to consider as the reference. If you consider I2 as the reference, then the net current flowing through 4 ohm resistor is, considering I2 as the reference, it is I2 minus I1 upward. When you consider I2 as the reference, the voltage drop will be in this way, plus minus, and Vx will be equal to minus 4 into I2 minus I1, okay, minus 4 into I2 minus I1. But if you consider I1 as the reference, okay, consider I1 flowing downwards, that as the reference, then, okay, let me draw it again. If you consider I1 as the reference, then the current flowing will be I1 minus I2, the polarity will be same as the voltage drop polarity which is being asked in the question. So in that case, it will be 4 into I1 minus I2, which is the same thing, okay. If you multiply it here, if a minus sign comes inside, it will be I1 minus I2, so it is the same thing. So whichever one you want to write, it will be the same thing, okay. So Vx is equal to this, this is the second important equation, sorry, third one, 1, 2, 3. Now all we have to do is find the mesh equation for this, and we'll solve it and we'll get the values, okay. So already we have got the 3 equations. Now we have to put KVL in this third mesh and we'll get all the required mesh equations. So putting KVL here in this third mesh, it will be 2Vx minus, considering I3 as the reference here, minus 2 I3 minus I2, because I3 and I2 they are flowing in opposite directions, okay, through 2 ohm resistor. So it will be minus 2 into 2 ohm resistor into I3 minus I2, both flowing in opposite direction. I3 minus I2 is equal to 0. Here we have to substitute the value of Vx which we just calculated previously, which is 4 into I1 minus I2, to bring it in terms of I1, I2 and I3. So we'll substitute this value. Vx is equal to 4 into I1 minus I2. So it will be 2 into 4 into I1 minus I2 minus 2 into I3 minus I2 is equal to 0. Simplifying it further, it will be 8 into I1 minus I2 minus 2 into I3 minus I2 is equal to 0, or we can write it as 8 I1 minus 8 I2 minus 2 I3 plus 2 I2 is equal to 0, or it is 8 I1, this is minus 6 I2 minus 2 I3 is equal to 0. So this is the fourth equation. Now we just have to solve them. Okay, so let us solve them. So now if you compare equation 2 and equation 4, see here it has plus 2i3, here it has minus 2i3. So if we add them together, okay, equation 2 which we got previously and equation 4, if we add them, i3 will be eliminated. We will get in terms of I1 and I2, the value of I1 we already know. So let us add them and we'll get the value of I2. So if we add them, it becomes 8 plus 4, 12 I1, and minus 12 plus minus 6 is minus 18 I2, and this is 0. 12 I1 minus 18 I2 is equal to 0. The value of I1 is 5. So I2 is equal to 12 by 18 into I1. So 2, 3, which is 2 by 3 I1, which is equal to 2 by 3 into 5, 10 by 3 ampere. Okay, the value of I2 is 10 by 3 ampere. Now for VTH calculation, let us write it here. The value of I2 is 10 by 3 ampere. This is the fifth equation. Now VTH is nothing but the voltage drop across this 6 ohm resistor. Why? Because 0 ampere current is flowing through 2 ohm. So VTH is simply the voltage drop across this 6 ohm resistor, which is nothing but 6 I2. I2 value we know. So VTH is 6 into 10 by 3, which is equal to 20 volt. VTH is 20 volt. The value of VTH we have got. Okay, the value of VTH. Okay, now we have to find the second part, which is the calculation of RTH. Okay, so let us do that. Okay, so we have calculated the VTH, Thevenin voltage. Now we have to find the Thevenin resistance. Now this is a very interesting thing when it comes to Thevenin resistance calculation or equivalent resistance calculation for circuits involving dependent sources, be it application of Thevenin theorem or application of Norton's theorem. There also the calculation of equivalent resistance follows the same principle. The same principle which we are using here to find RTH, the same thing we will be doing in Norton's theorem for equivalent resistance calculation. So there are three ways of doing it. Okay, three different ways in which we can determine Thevenin resistance. So I will be discussing one method in each of these questions. I will be discussing around 5 to 6 questions. So I will be discussing one method of determining RTH in each of these questions. Otherwise, if I explain three methods in one question, it will be becoming very lengthy. Okay, so I will be discussing one method of calculation of this equivalent resistance or RTH in each question. Okay, so in circuits involving independent sources, what we used to do is that we simply deactivated them. Current sources were open circuited, voltage sources were short circuited, and then we just found the equivalent resistance between these two terminals across which the RTH was asked. But here the problem comes because of this dependent source. So here the first method is we will be deactivating the independent source. Here in this case it is the current source, we will be open circuiting it, so it will go out of this question. But as there is no independent source present, we have to use our own independent source to excite the circuit. Normally a unit voltage or current source is used. In the first method we will be determining the RTH using a 1 volt voltage source across the terminals across which the equivalent resistance is to be calculated. Let the current supplied by this 1 volt voltage source be I0. Thevenin resistance is simply 1 volt by I0 ampere, no matter in which units, 1 by I0. So here the main task is to find this I0. We have to find I0, then we can calculate this RTH, 1 volt by I0, equation number 1. So again here we will be using mesh analysis method. So here another important thing is to define Vx. So for that we have to assign the mesh currents. Let us say this current here is I1, this current is I2, this current is I3, all in clockwise direction. So some important relationships will be coming up. RTH is 1 volt by I0, that is the first relationship. Let me erase this. Another important relationship is that I0 is equal to minus I3, they are opposite in direction. I0 is equal to minus I3, that is equation number 2. Okay, I am writing here so that there is enough space here. I0 is equal to minus I3. Another important relationship is Vx, the value of Vx. So here Vx is the voltage drop across this 4 ohm resistor. It is in this way, the polarity which is being asked in the question. But the current is flowing, the I2 current is flowing in the opposite direction, I2. So the actual polarity will be like this. So Vx is equal to minus 4I2. Why minus? Because the polarity which is being asked in the question and the current which is flowing through the resistor as per our sign convention which we have taken in the clockwise direction, it is opposite. So the polarities are opposite, that's why it is minus 4I2. This is the third equation. So these relationships will help us to solve the question. Okay, so now let us write the mesh equation for each of these meshes 1, 2 and 3. So for the first mesh we will be writing the equation. So it is 2Vx minus 2, considering I1 as the reference, I1 minus I2. Why? Because I1 is flowing from right to left, I2 is flowing from left to right. I1 is the reference, that's why I1 minus I2, that is equal to 0. But Vx is equal to minus 4I2. So we'll substitute Vx with 4I2, which is 2 into minus 4I2 minus 2 into I1 minus I2 is equal to 0, or it will be equal to minus 8I2 minus 2I1 plus 2I2 is equal to 0, or we can write it as minus 2I1 minus 6I2 is equal to 0. This is the fourth equation, minus 2I1 minus 6I2 for mesh 1, this mesh. Minus 2I1 minus 6I2 is equal to 0. So let us write it here, minus 2I1 minus 6I2 is equal to 0. Now let us do that for the second mesh also. For the second mesh, it is minus 4I2, this minus 4I2, here I2 is the reference, I2 is the reference here, so here it will change, minus 2 into I2 minus I1, because I2 is the reference. The mesh in which you are applying the KVL equation, that mesh current will be always, you will be write the mesh equation with that mesh current as the reference always. It will be simple for you. So here it is minus I2 minus I1. In this case it was I1 minus I2. In this case it is I2 minus I1. Minus 2 into I2 minus I1. Again minus 6 into I2 minus I3. Always I2 is the reference. Thus I2 minus I3 is equal to 0. That implies minus 4I2 minus 2I2 plus 2I1 minus 6I2 plus 6I3 is equal to 0. So bringing all the coefficients together, it will be 2I1 minus 4I2 minus 2 minus 6I2 minus 12I2 minus 12I2 6I3, only 6I3 is there, okay, plus 6I3 is equal to 0. This is the fifth equation for the second mesh. Okay, so let us write it down here, 2I1 minus 12I2 plus 6I3 is equal to 0. This is the fifth equation. Now the final, this mesh, the third mesh, we will be writing the KVL equation, and then we will be substituting. We can use whatever method to determine the value of I0. This is our main objective, to find the value of I0. So writing the equation for this third mesh, it is minus, here I3 is the mesh current, so that will be the reference, I3 minus I2, minus 6 into I3 minus I2, minus 2I3 minus 1 is equal to 0. That implies minus 6I3 plus 6I2 minus 2I3 is equal to 1. We have taken the 1 to the right hand side. That implies 6I2 minus 8I3 is equal to 1. Or we can write it in proper format as 0I1 plus 6I2 minus 8i3 is equal to 1. This is the sixth equation. Okay, now we have to solve these equation number 4, 5 and 6. So we can use whatever way, Kramer's rule we can use, that will be a lengthy method, but if in your college scientific calculators are allowed, you can go to the 3 equation mode, put the values of these coefficients and get the results. Here I have already discussed the Kramer's rule of solving mesh equations in the previous video related to mesh analysis. You can check that out there. Here I will be directly calculating the values. I will be not discussing about Kramer's rule here. Okay, I will be directly finding out the values using scientific calculators. Okay, so let us put the values. So we put the values of the various coefficients in the scientific calculator and we got these results. The value of I1 is 1 by 6 ampere, I2 is minus 1 by 18 ampere and I3 is minus 1 by 6 ampere. Now our interest is with this I3 because RTH is 1 volt by I0, I0 is minus I3. Okay, 1 volt by I0 for RTH, I0 is minus I3. So I0 here is minus I3, which is 1 by 6 ampere. RTH is 1 volt by 1 by 6 ampere, which is equal to 6 ohm. Okay, 6 ohm. So RTH here is 6 ohm. So VTH we got as 20 volt, I think VTH was 20 volt and RTH is 6 ohm. So we got the two results for this circuit. It was a bit lengthy because there was a 3 mesh involved in each of the circuit analysis, so a lot of mesh equations. So we solved the circuit. VTH 20 volt, RTH 6 ohm. So I hope you like this video and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.